Welcome to Are You Ready? With your Bible teacher, College Quillo. What's happening in the world? Let's look at the Bible.
Welcome, everybody. Thank you for joining us this evening on Are You Ready? I'm. As you can see, we have a very, very special guest, and I want to thank all of you watching all over the world. Please subscribe to Are You Ready? Click notification and share this video with as many people as possible. So today we have a special guest. A lot of people have been talking about different volcanoes around the world. And of course, the one we have here in America, Yellowstone Supervolcano. So today we have Mike Poland. He is, I believe you're the person in charge of the Yellowstone Supervolcano, and he works for the USGS, correct?
Yes.
Yes, awesome, fantastic. So this is a great to have you on the program. We have lots of questions for you. It's an honor to have you on. I thank you for being on the program. Can you let us know a little bit about yourself before we get started?
Yeah, so I'm serving right now. I'm a geophysicist with the U.S. Geological Survey, and my specialty is looking at how the ground moves up and down, crustal deformation. And volcanologists use that sort of information to try to understand where magma might be beneath the surface, how much magma there is, whether or not it's rising or moving someplace. And I also serve as the scientist in charge of the Yellowstone Volcano Observatory. And that's not a physical facility. It's not a building that's next to Yellowstone or anything like that. It's more of a group of different agencies that monitor and study Yellowstone. It consists of the National Park Service, the University of Utah, the University of Wyoming, Montana State University right there in Bozeman, a group called UNAVCO that specializes in crustal deformation, the State Geologic Surveys of Idaho, Montana, and Wyoming. So it's sort of a group of scientists that are tasked with trying to understand how Yellowstone works.
Very good. So you got lots of experience, lots of experience. So what we want to do today, because when you ever invite anybody on the program, I like to start with the basics. And I'm sure some people, I know what that is, but just in case, and you're a person that knows about that, what is a volcano and what is the difference between a volcano and a super volcano? We can start there.
Sure. Well, a volcano is really just a place where the heat that's in Earth's interior is escaping to the surface. Earth is still a hot, relatively young planet. And so it has a lot of heat that's trapped in the interior, and it needs to get out. And so volcanoes provide a mechanism for that. And you get different volcanoes forming mostly on the seams between the big tectonic plates that make up the surface of the planet. But there are also a couple of places, more than a couple of places, a few places around the world where the volcanoes sort of punch through the interiors of the plates due to some melting anomalies that are sort of away from the seams. And those are hot spots. Hawaii is sort of the classic hot spot, but Yellowstone is also a hot spot. Now, as for the other question, a supervolcano, I have to admit, I really don't care for that term. I think it's really kind of misleading. It's used a lot of times inappropriately. And so I prefer to think of these as caldera systems. And what makes them special is that they're big. And caldera systems, or supervolcanoes, have experienced eruptions of a size that kind of empties the magma chamber. Mm-hmm. And so the ground above them collapses, and you get a very large crater, what we call in geology a caldera. And so that's kind of the difference is these volcanic systems are so big, they've had eruptions that are so big that they cause the surface to collapse. But that's not the only kind of eruption they have, and that's sort of the case with Yellowstone. It has lava flows far more often than it has the really large explosions.
And of course, the large explosion will be the worst. That's the thing you don't want to happen, correct?
Right. Yeah. So there are, even though I don't care for the term supervolcano, I think it's kind of misleading. We do use the term super eruption, and that corresponds to an eruption of a size, of a certain volume, of a certain magnitude. And Yellowstone has had a couple of those in its past, and so those are the really large eruptions that can have a global impact on climate, for example. Really events that you wouldn't want to see.
No, exactly. And we're going to talk about some of that today. No, and I think you just mentioned it. What causes the magma to rise? Can you repeat that?
Sure. So magma ascent is caused really kind of like buoyancy. It's the magma when it gets, especially when it's gas charged, then it wants to rise because it's not that dense. It's warm and bubbly and it wants to get to the surface. And as the magma ascends, as it gets closer to the surface, there's less and less pressure on it. And that allows bubbles to come out, bubbles to form, sort of like opening a can of Coke. And that makes the rise even faster. So you can get these runaway situations. And that's what drives a lot of explosive eruptions, is as the magma rises, bubbles come out, which causes it to rise faster, which causes more bubbles to come out. And then when it gets to the surface, it's sort of a runaway process.
And that's what you don't want to happen, correct?
Right. That's what you can give you really explosive eruptions. But that's for types of volcanoes that have magma that's really sticky and that hold on to the bubbles. There are other types of volcanoes. Kilauea in Hawaii is a good example of the magma's sort of more runny. It's not quite as sticky, and the bubbles can get out a little easier. So really explosive activity in places like Hawaii is rarer because the magma doesn't hold on to the bubbles as tightly as when the magma is sticky.
And so that's what causes it for more eruptions? Is that what you're saying?
Well, the difference is sort of in the explosivity. So in places where you've got really sticky magma, you can have large explosions. And where there's not so sticky magma, you tend to get runnier types of eruptions where the lava flows sort of spread out along the surface, and they're almost tourist attractions. What's happening in Iceland right now is
yes. You want to talk about what's happening in Iceland?
Well, sure. It's Iceland is one of the most volcanically active places in the world. It sits right on one of these seams between the tectonic plates on the surface of the Earth, and there is one of these melting anomalies beneath it as well. So you have this sort of double whammy in Iceland that results in lots and lots of magma being generated. And so eruptions there are pretty common, but for the most part, they tend to not be of the really explosive variety. They tend to be sort of the runny style that we'd see in Hawaii. But every now and then you can get explosions, especially because there's a lot of ice in Iceland. And when you mix that magma and lava with water and ice, you can get some explosions. And that's what happened in 2010 when airspace, between Iceland and Europe and sort of all over Europe was closed because of all the ash that was generated by that interaction.
Correct. And what is the difference? What just happened recently? Is between this one happened recently and what happened in 2010? Can you explain that difference? Sure.
In 2010, that one happened at an ice-covered volcano. And so you had that explosive mixing of lots of water and ice and the lava that was coming to the surface. The eruption that's happening now is in an area that's not ice-covered. It's an area on the Reykjanes Peninsula. So it's sort of that peninsula that sort of juts off to the southwest part of the island. And that's an area that's spreading. It's spreading apart. And so magma takes advantage of that space that's created. And every few hundred years, it's able to make it to the surface. But because there isn't that really thick ice cover and lots of water on the surface or near the surface, you don't have that really explosive mix.
That's the difference between the two.
Yeah, exactly. Okay.
Now here's a question, because you hear about people saying, and they keep an eye on the earthquakes, right? Mm-hmm. Now, how do earthquakes around the world can they affect Yellowstone? Does it have to happen right at Yellowstone, or if let's say a 7.5 happens somewhere else, will it affect Yellowstone?
It's sort of an interesting question. I get this question a lot, like, will Yellowstone be triggered by an earthquake? And it won't be. And we know that because it's happened many times in the past. The largest earthquake ever measured in the Intermountain West was a magnitude 7.3 in 1959. And it happened right on the edge of Yellowstone National Park, just across the border into western Montana. It was the Hebgen Lake earthquake. It actually resulted in the deaths of 28 people. It was a really big event. It didn't cause any sort of earthquake or volcanic activity at Yellowstone. So those big earthquakes, whether they're real close to Yellowstone or whether they're quite far away, it doesn't cause eruptions. It can result in changes in the hydrothermal system. And that's the geyser systems, the hot springs, the hot pools. And that's because the plumbing systems for those pools are pretty delicate. So you could imagine it like maybe the plumbing system in a really old house. The pipes are rusted and things don't quite work right. And then if you shake that plumbing system, pipes might break or things might get rerouted. So after that 1959 magnitude 7.3 event, there were actually a whole bunch of geysers and hot springs that erupted somewhat unexpectedly. They weren't things that normally erupted. So you can shake up that plumbing system, and that can generate a lot of geyser activity. But you're not going to trigger an eruption at Yellowstone by having an earthquake, whether it's right nearby or whether it's quite far off.
So it isn't like the movies I've seen.
Yeah, it is funny. It's sort of, this is the most common question. Whenever there's an earthquake, back in March of 2020, there was a magnitude 6.5 in Idaho. Back in 2019, there was a magnitude 7.1 earthquake in California. And there's always a lot of questions about, is this going to trigger Yellowstone? And the simplest way to say it is, the last time Yellowstone erupted was tens of thousands of years ago. It was a lava flow. There have been thousands of magnitude 6, 7, 8, maybe even 9 earthquakes that have occurred in the U.S. since that last eruption, and nothing's happened at Yellowstone. So Yellowstone, the magma chamber we know there is mostly solid, so it just doesn't have anything that can get really stirred up. But the hydrothermal system, though, all of those geysers and hot springs, those are the things that will react to earthquakes.
They will react to earthquakes. Okay, but not an earthquake. Not if a major earthquake happens in the U.S., it's not, even if it's even close, like you said, it wouldn't affect Yellowstone. The Yellowstone super, as you say, the super eruption won't occur.
Right, exactly. And we know that because that experiment happened in 1959. A magnitude 7.3 is a pretty big earthquake. That's one of the largest sizes you can get in the Intermountain West. And it caused a lot of geyser activity, that's for sure, but it didn't stir up the volcano any.
Okay, the next question I have, this is, it might be like the movie kind of thing, but because I've seen, my wife and I have been watching a lot of, disaster movies, and so, I don't know, of course, a lot of these movies are, they make them bigger than the reality to make people watch, but can the USGS prepare or warn people of a volcanic eruption? Because the reason I ask this is because I've checked a few of the volcanoes that have erupted recently. And one of the words that the USGS has used is suddenly. Didn't expect. I think there was one in, I don't know, it was another, Stromboli. The one in Italy. They said the people there said they didn't expect it. They weren't expecting it. Now, is there any way, I don't know, only God knows, but can you let's say, can you prepare people, say an eruption is about to come?
Yeah, this is possible. So I'm not sure of the example you're saying. Something like Stromboli, say, or Etna, it's a little bit harder to predict when something may ramp up because those volcanoes are erupting all the time anyway. Okay. And that's something I think isn't commonly known. That Etna in Sicily has had some amazing lava fountains over the last few weeks and months. One of them was a mile high, incredible stuff. But Etna is always erupting, and so that's not new activity. It's sort of perhaps a ramp up in that style, and there are some indicators. But these are volcanoes that are always erupting anyway, so it's sort of the throat has been cleared, and they're already quite active. A place like Yellowstone that has been so quiet for so long, in order to get it going again, you would see all kinds of changes. There would be tens of thousands of earthquakes, many of which would be felt. The ground would be rising at really noticeable rates, possibly meters per year, and tens of feet per year. There would be changes in gas emissions and thermal emissions. It would be unmistakable. And those warning signs are designed to be registered by all of the instrumentation that's installed around Yellowstone. Continuous GPS stations, which track how the ground moves, and seismometers, which look for shaking, and satellites, which can measure just how much heat is being emitted. So I occasionally have people say, well, Yellowstone could erupt tomorrow and you wouldn't know. And that's something I can guarantee won't happen. Yellowstone will not erupt tomorrow because we would see signs. It has to wake up. It has to get going.
Correct.
It's sort of like a car that you haven't started in ages and ages. You're not just going to put the key in and start.
That's true.
Engine over. It takes a little bit to get going, and those are the signs that we work on detecting. And at volcanoes where it hasn't been very active in a while, there's a correlation that we see the ramp up. And so that's what the networks at volcanoes are designed to do, is detect those ramp ups so that we can issue warnings.
Right. So it's not something that can just boom happen overnight.
Right. I mean, one thing that could happen at Yellowstone on a rapid basis would be a steam explosion, and that's basically water underground that instantaneously flashes to steam, and then you get an explosion. It's sort of like a hyper geyser eruption. That can happen with very little warning, but that's not necessarily related to the volcano. That's related to sort of steam pockets getting trapped and water boiling underground, and then it can explode outward. And that's sort of what geysers do all the time. But anything involving magma, that's going to take a while at Yellowstone, because that magma chamber beneath the surface is mostly solid. So you'd have to start melting more of that and moving it, and that's going to cause all kinds of signs that would just be completely unmistakable.
Well, this you mentioned magma, because I've seen people measure that the magma moves by an inch or rises by an inch or two. Is that? I mean, it would have to rise a lot, right? It may be a
right now the magma chamber beneath Yellowstone is about 3 miles beneath the surface. That's where the top of it starts, and it's a very impressive magma reservoir. But only about 5 to 15% of that is actually molten. The rest of it is sort of hot, plastic, mushy rock. So the amount of molten material beneath the surface is small compared to the overall size of the chamber. It's not rising right now. The ground can rise and fall. And this is another misconception about Yellowstone. I often hear people say, well, but the ground is uplifting, right? Actually, since 2015, Yellowstone has been sinking, but it goes in waves. From 2004 to 2010, it was rising. And then 2010 to 2014, it was falling. And then 2014, 2015, it rose. And 2015 to now, it falls. And it's only about an inch or two per year. So it's almost like Yellowstone is breathing. And we believe that's because of all of that water that's moving around in the subsurface. It accumulates and pushes the ground up, drains out, the ground sinks back down again. So that water moving around in the subsurface that's feeding all the geysers and hot springs really has a huge impact on what we see at the surface.
Wow. You got a lot of knowledge.
Thank you.
Thank God for that. Okay. Let's see. Okay. Now, I know that there are some. Are there dormant volcanoes that you know of?
Oh, sure. It's the terminology is sort of hard to use, because what does dormant mean? Does that mean potentially active but not erupting right now? I think different people use it in different ways. So, for example, Mount Rainier, you could say that one is dormant. It's active in that we expect it to erupt again at some point, but right now it's quiet. Mount St. Helens, in fact, just about every volcano that we consider active in the lower 48 right now is also dormant. It may erupt in the future, probably will erupt in the future, but we're not seeing any signs right now. So yeah, there's dormant volcanoes sort of all over the world that we expect will erupt again someday, but they're quiet right now.
They're quiet right now. Okay, and then I think you said to see that it's going to erupt, you would see an increased amount of magma rising. Correct? Yeah.
So as magma rises, it has to push all of the rock out of the way as it's going to go up, right? It's not just going to, it's not like it's going through a sponge. It's going through solid rock. So it pushes that rock out of the way. And when it does that, it creates huge numbers of earthquakes, and it'll force the ground up as well, almost like an inflating balloon. And so that's why two of the big indicators we look for are really abundant seismicity and then really noticeable ground inflation. But it's important that we know what the background is. Some places are noisy. Yellowstone, because of all of that hot water moving around in the subsurface and the fact that there's all these faults all over the place there, it's a noisy place. So the background at Yellowstone, you get about 2,000 small earthquakes every year. And what we're looking for is something that's on top of that background. So the ground rises and falls a couple of inches per year. That's normal. 2,000 earthquakes or so a year. That's normal.
Mm.
But what if we saw 10,000 earthquakes in a month where the ground rose by several feet? That's not normal. And that's when there's a sign that something's going on.
And see, that's what I read you said in an article, that you said that it would need to be 10,000 or more earthquakes to really begin. Wow, we got something coming, right? We're going to worry a little. We're going to start worrying now if we get that many earthquakes.
Yeah, we wouldn't put an actual number like, 10,000 is when we start worrying, and anything less is fine. But, it's that sort of scale. We see thousands of earthquakes every year on average anyway. That's normal for Yellowstone.
Right.
That's the way it is. It's when you see big deviations from that background that you start to say, okay, something's different, and then you have to understand what's different. And at Yellowstone, there is a possibility that magma might be involved in making a different kind of situation.
Wow. Okay, so that. Okay. Oh, all right. Here's a what if question.
Mm-hmm.
All right. This is a hypothetical. Hypothetical, and this is like the movie kind of hypothetical thing. What if Yellowstone supervolcano, let's say it did have, like you said, thousands, tens of thousands of, 10,000 or more earthquakes, and the magma was rising up more than very unusual. What if that Yellowstone supervolcano erupted? What would it cause? What would be the effects of it if it ever did?
Well, it depends on the style of eruption. So, of course, most people know Yellowstone as being the super kablooey, right? Giant explosions.
Right.
And those happen, right? The last one happened over 500,000 years ago. They typically happen 1 or 2 per million years when you sort of look at the long geologic scale of it. And that would be, pretty disastrous. You'd have very thick sheets of ash that would kind of wipe the area clean for, maybe a couple hundred miles away from Yellowstone. But then farther from there, you would have a lot of ash just falling, and that would have a problem for agriculture and for structures. You put a lot of ash on buildings, and they'll collapse if there's enough ash. Electricity, water supplies, there's all kinds of issues that would cause. And globally, you would have so much ash and gases in the atmosphere that it could lower the temperature. That's happened on a smaller scale with historical eruptions. In 1991, Pinatubo erupted, and it lowered the global temperature by an average of about 1 degree Fahrenheit.
Wow.
So these sorts of things would have a really big impact globally. However, what's more common at Yellowstone are lava flows. So since that last big explosion, 500,000 years ago or so, there have been about 20 lava flows. And those lava flows are, while not just like what you see in Hawaii or Iceland, they are not accompanied by massive explosions. And so if it was a lava flow, it would probably be a pretty big tourist attraction. There wouldn't be all of that ash and devastation. It would just be sort of the area of the lava flow that would be damaged. And of course, that could do a real number on roads and buildings and things like that if it were in the right place. But it wouldn't be something that would cause devastation over a broad area. It would sort of be restricted to the park itself.
Okay, but going back to the what if hypothetical, if it did erupt and it was that kind of the ash, now, because I've seen some videos that it would spread. Most of the U.S. would be covered in ash. Would you say?
Yeah, it as you get further and further away from Yellowstone, the amount of ash cover would decrease. So it's sort of densest right towards the center, and then it thins as you move away from the center. But if you get a few inches of ash, even it's a difficult thing to clean up and cope with. So it would certainly be a problem. It wouldn't mean that we were all going to die.
Okay.
It would be really unpleasant, and there would be a lot to adapt to. There would be an awful lot of things to adapt to. But human beings are also pretty adaptable. It wouldn't be fun. I wouldn't want to live through that. But it wouldn't be the end of humans.
Okay. Because I thought what I heard is that if the person breathed the ash, it would affect their lungs. Is that true?
It can, yeah. So you don't want to be standing out there in a ashfall and just breathing in huge chunks of this. That's why you normally see people with bandanas or something over their face in pictures, say from Mount St. Helens in 1980. You see people with bandanas, wet T-shirts that do just fine over your face. You want to sort of filter that out, just like in sort of a forest fire. You don't want to be breathing that ash in either. It's not great for your lungs. But the ash itself, it's not toxic. You just don't want to have a whole bunch of particles, in your airways. It'll make breathing kind of difficult.
So the ash you're saying the ash is not toxic, but you don't want to be breathing it, too much of it.
Yeah, the ash is pulverized rock, and so it's not on its own toxic and deadly. But you don't want to be breathing rock fragments. Just like if you're working in a shop or you're a tile cutter or you're working as a mason cutting bricks and so forth, you usually will wear some sort of respirator or dust mask or something just to keep from breathing all that dust.
Okay. Here's another question. Going back to the what if, I got a lot of these what ifs here. What if this did happen? Where should one live in the U.S. if this kind of an eruption did occur? Hypothetical.
Well, the key to any sort of eruption is being out of the way. We don't have any ability to stop eruptions, large or small. You can maybe divert a lava flow. You can sort of try to send it on a different path. But explosive eruptions, especially, whether they're large or small, we don't have any ability to stop or change their trajectory. So the key is to not be near the area of an eruption. And that's why the evacuation is the best measure for any sort of hazard response. And you've seen that, for example, in the Caribbean. There was an eruption in April, an explosive eruption. And people got out of the way and no one died, to my knowledge anyway. And so that was really sort of impressive. The volcanologists saw the signs that something was about to happen. People left the area at the urging of the sort of local experts and the local officials, and they were okay. So you wouldn't want to be right in the area of sort of the really dense ashfall, which is that area sort of all around Yellowstone, a few hundred miles out. Outside of that, you're going to be dealing with ash. Now, sort of you go to the corners of the country farthest away from Yellowstone, and you'll see less ash than closer in. Mm-hmm. But it would impact all of us, even if you didn't have much ash fall in your area. Right. You, of course, will be relying on things that are grown in states that maybe do see some impact. So I think even if you didn't feel the effects of ash fall directly, you would still feel the effects of the eruption in some way. So it's I don't know that there would really be a great place to be because it would hurt, right? I mean, even if you're not directly impacted by the ash, you would feel the effects of that it had on more local areas.
But I believe, as you mentioned, the supply chain will be totally disrupted. The moment that happens, there will be none.
Yeah, I mean, we've seen sort of the effects of the supply chain that COVID had, right? And you can imagine just how devastated it would be if it was a real natural disaster that disrupted the supply chain.
Wow, that's so true. That's so true. Okay. Okay. Now, I think we went over this. What if? Because this comes to my mind. A lot of the Latin American countries, they build their homes around volcanoes, villages, and which I've always found odd, building your house near the volcano, because at any moment it could possibly, right? So what would you say is that a good idea to live near a volcano? I mean, it's a beautiful sight.
Well, I can't sort of speak for people that live in other countries because I'm not in their situations. But volcanoes have advantages as well. The soil around volcanoes is incredibly fertile.
Really?
So you can grow a lot of things on a volcano that you might not be able to grow elsewhere. And so if your day-to-day worry is feeding your family and making sure you have enough to live from, you may choose to live in such a place because it offers you the opportunity to sort of provide for your family. So, and there's a lot of places where the population is just so dense, there's no choice. Indonesia is a classic example, or the Philippines. There's huge numbers of people that live on islands, and the islands, of course, are basically volcanoes. So you don't have much choice. This may be the only place you can live, and hopefully you can make a living off of the rich soils. So volcanoes are pretty good for agriculture, and I can see why that's probably why a lot of people live there. And then you sort of have to take the good with the bad. I think some people in Central American, South American countries may look at the U.S. and think, why would anyone live in Tornado Alley or along the Gulf Coast with hurricanes or something like that? So
good point. That's very good. That's true. Because they have no choice. A lot of them have no choice.
Yeah, absolutely.
Where to live. Okay. One last thing I want to ask you
Sure.
Before we finish today. And once again, thank you for being on the program.
Yeah, my pleasure.
What would you want to say to people when it comes to the volcano? What should let's say here, talking to Americans in America, what should Americans be looking at? Should they be worried, not worried, or let it ride, forget about it, don't even think about it? What would you say to them?
I'm not worried about a Yellowstone eruption. That system is quiet right now, and it would take a while to get it going, like that car you haven't started in quite a long time. There are other hazards which I think are probably more important to people on a sort of daily basis. If you live in the Gulf Coast, Category 5 hurricanes. If you live in Tornado Alley, or you may live in a floodplain where floods come through every few years, or maybe you live in the Pacific Northwest, and there's the potential for large earthquakes, or volcanoes in the Pacific Northwest are much more active than Yellowstone. So in my mind, Yellowstone really is not a hazard on human timescales.
Okay.
The sort of ramp up we would need, it's going to take a while to get all of that magma flowing and molten, and it's just not the kind of thing that happens on human timescales. But I have no doubt that in my life we will see earthquakes along the western half of the country, strong ones, and floods in many parts of the country, and big hurricanes and massive tornadoes. So I think really the message ought to be about knowing the area in which you live and the sorts of hazards that you're likely to experience. It might be a flood, it might be an earthquake, and knowing sort of what that entails. How will you respond if your area is subject to a flood or a tornado, and having sort of a plan to go along with the hazards that are most likely to impact you.
Exactly. I think that's very important for people here on Are You Ready to know that you need to be prepared, right?
Yeah.
Be prepared.
Knowledge is power.
That's right. And what I've noticed in the past, everybody always waits for the last minute, right? Some people always wait for the last minute. The hurricane coming, and then, man, I better go get some flashlights.
Yeah, I need to get some battery or something. Yeah.
One thing I learned is to be prepared. I got plenty of stuff just in case.
Yeah. Listen, there was no toilet paper back in March, right? In March of 2020.
Exactly. So it's good to be prepared.
Yeah.
Well, I want to say thank you, Mike Poland, for being with us with the USGS. It's been very informative, the information you have given everyone here on Are You Ready? And I want to say to everyone watching, if you watch this video, please share it with as many people as possible. Subscribe to Are You Ready? And click notification. And thank you for being with us today. And please share it, okay? Be prepared. Don't wait till the last minute, okay? Mike, thank you for being with us, okay?
My pleasure. Take care.
Thank you very much, sir. I appreciate it. Have a great day. Bye-bye.